Hello everyone and welcome to another video on building Spring-based applications on AWS serverless technologies. In this video, I'm incredibly excited to be talking to you about Lambda SnapStart. Lambda SnapStart is a feature announced at reInvent to reduce the cold starts of your Lambda function. It does this by getting the init phase of your Lambda function to happen when a new version of your Lambda function is published. And that initialized version of your Lambda function is then snapshotted and cached. And what that means is that when a new request comes into your Lambda function, rather than the execution environment needing to be created, your function downloaded and the initialization to happen, that execution environment is created from a cache. Now, this means that when I publish a new version of my Lambda function, I can't use that version of my Lambda function until a point in which the snapshotting has completed. And we'll get into aliases and versions in just a few minutes' time. So before we get into SnapStart, let's just level set and look at what the execution time of our SpringBoot API is right now. And to do that, I'm just going to hit my API endpoint for my API. And we can see we've got a little bit of a wait here. If you've used Spring on Lambda before, you'll know that cold starts can be a challenge. And eventually we've got a response back from our API. If I now go off to the CloudWatch logs for this function, we can actually have a look at what the duration of that initialization was. So if we now go and open up this latest log stream, and we can see the logs for that invoke of our API. And if we go and have a look at this report log line at the bottom, we can see that our total duration of our Lambda function was the init duration, which was 6.8 seconds. It took nearly 7 seconds for this SpringBoot API to start up and Lambda to initialize. The actual execution of the API request was only 355 milliseconds. So that total request time, actually only 300 milliseconds of that was our actual application code. And this is exactly what SnapStart is built to address. So let's go back to our Lambda console now. And if I switch over to my configuration window, you can see that I've now got this SnapStart configuration option. If I edit the configuration of my Lambda function, and I can switch that to published versions. Now when I save that, that's not instantly going to enable SnapStart. SnapStart only kicks in when I publish a new version of my Lambda function. Now I'm going to dive into aliases and versions in a lot more detail in a later video. But for the purposes of this video, within Lambda, there is the concept of what's called an alias. So in this case, I've got an alias of production for my Lambda function, and I can point my API gateway at a certain alias. So in this case, the API gateway that's sourcing this Lambda function is pointing to my production alias. An alias can then be linked to a specific version. So you can see it here, 100% of the requests that come to the production alias will be routed to version 27 of my Lambda function. That's the one we've just invoked and seen. If I switch over to the versions tab now, I can come into here and publish a new version of my Lambda function. So if I hit that publish version now, and I type enable SnapStart and hit publish, this will now create a new version of my function. And you can see I can actually get in the log messages at the top of the screen that SnapStart is going to add a few minutes to this version creation process because, of course, in the background now, the Lambda service is initializing my Lambda function and taking a snapshot of that initialized environment. Now, if I actually go off to CloudWatch now, I can see this in action. If I come back to my log streams, you can see I've got a whole new set of log streams here. These are the logs that are being written for the initialization of my function. So if I open up one of these log groups, we can see some of the same application code that we saw in the invocation. And actually you can see that I'm getting a report here that the initialization duration was 5 seconds. So it took 5 seconds for Lambda to initialize this and then snapshot the function. This can take a couple of minutes for the snapshot to happen, so I'm just going to pause the video here and we will come back when it is complete. Okay, so we can see we've now got our new version. We've got version 29 of our Lambda function. So if I come back into here and look at my versions, we can see I've got version 28, which is still linked to production, and then I've got version 29, which currently isn't being invoked. And like I said, I'm going to do a later video on how to build this into your CI/CD process and how you can automate a lot of this switching. But what I'm going to do now is come back to my Aliases tab, and I'm going to switch my production alias, instead of pointing at version 28, to point at version 29. So now my API is pointing at the SnapStart enabled version of my Lambda function. I'm going to come back to my API endpoint now, and I'm just going to hit the refresh on my API. And you can see that has returned much quicker. Now that was a cold start. That was a brand new version of our Lambda function in a brand new execution environment. And you can see just from looking at that, it was much faster. And that's because SnapStart is now using this snapshot of our image and restoring that, as opposed to initializing our Spring API from a standing start. Now let's go and have a look at our CloudWatch logs, because we can actually see the difference in the logs. If I take my latest log group here from the invoke I've just used, and you can see we've now got a slightly different structure to our log group. We've got this restore duration up at the top, and you can see it took the Lambda service 392 milliseconds to restore the snapshot of our function. And if we then take a look at this report line at the bottom, we can see the different times that different parts of our application took, and we can work out our total cold start by combining both our duration, which is 406 milliseconds, and our restore duration, which is 392 milliseconds. So that gives us about an 800 millisecond cold start from 7 seconds from the API at the start. That's an incredible performance impact without me changing a single line of my application code. I can just enable SnapStart and the rest just happens. It really is that simple. One thing I will point out with these timings is that this API is connected to a tiny little RDS instance in the backend, so that 406 millisecond duration is mostly taken up with our database query. However, there are a couple of additional configurations we can make inside our application code to help work with SnapStart. We can do things before a snapshot is taken and also after a snapshot is restored. Now let's go off to IntelliJ now and have a look at what that looks like. If I open up my application code, you see I've got this snapshot configuration class. And this snapshot configuration class implements the resource class that comes from the CRAC project. Now the coordinated restore at checkpoint project is a feature of the OpenJDK, and I'll put some links in the description to describe that in more detail if you're interested in how that works under the hood. But what that gives us is the ability to override this before checkpoint and after restore method. And this is where we can put some code to do some quite interesting things to help make our application run as efficiently as possible. The important thing about before checkpoint is to close any connections, maybe get rid of any static data or in-memory data that you might not want to share between snapshots when they get restored. Because remember, this same snapshot is going to be used across all invocations of that version of your Lambda function. The after restore method, on the other hand, is where you could add some logic to potentially refresh your database credentials. If you're using rotation in Secrets Manager, the credentials that were available at the time of the snapshot may not necessarily be the same credentials that are there now. So that's where in AfterRestore you can start to ensure the state of the application from the snapshot is in the right way to then enable the functionality of your application. The other quite interesting thing that you can start to look to do in BeforeCheckpoint is to look at the hot paths in your application and actually pre-JIT some of that code. If I have a specific method or a specific service or a handler that I know gets a lot of traffic, I could actually run that method as part of BeforeCheckpoint. That's going to run at the point when my snapshot is being taken by SnapStart. Now when then my first request comes into Lambda and that snapshot is used to handle that request, that code has already been JITted. It's ready, it's efficient, it's performant, and it's ready to go. So these BeforeCheckpoint and AfterRestore methods are really interesting to add some additional use cases to your application. And I'm going to dive into some more specifics and some more use cases in some later videos. The other thing that's really important to remember at this point is that you register your snapshot configuration with the global context of the CRAC libraries. So what we need to do is in the constructor of our snapshot configuration, we just get the global context. It's a static property, and we can just register our snapshot configuration as part of the context. This register method takes in an object that of course inherits from resource, which is what we're doing here. And that is really all there is to enabling SnapStart for your applications. And of course, this demonstration here has been using Spring on Java. SnapStart is available for all Lambda functions using Java 11. So just to recap, before we enabled SnapStart, our Lambda function had an init duration of 6.8 seconds, and the actual execution time was around 300 milliseconds. All we did was enabled SnapStart using the configuration options in the console. This will be supported in CloudFormation and AWS SAM. I published a new version of my Lambda function, which then told SnapStart to take a snapshot. I switched over my production alias to point at that new version, and that then reduced my total execution time down to less than a second. That's completely free. There's no charge for SnapStart to get these awesome performance improvements to your Java-based applications. Of course, there are a couple of changes I needed to make in my application code, and there are considerations you'll need to make if you're doing things like secrets rotation for your database credentials. You will need to build a refresh into these hooks. And we'll start to explore some of these different use cases and some of these different challenges as we move forward through this series on SpringBoot on Lambda. That's all I've got today. This is an incredibly exciting release, and I would really encourage you to go and check this out. As always, if you've enjoyed this video, please like, please subscribe, and please share, and I will see you next time.